All right. So to recap, we took the favorable outcome, which was the entire square here. We said we needed to take out the circle. So we said square minus circle out of the whole square. Okay? So we found the area of the circle, which was 78.5. We found the area of the square, which was 100. And we just plugged that in to kind of our formula for thinking about probability. Okay? So let's go ahead and look at the second example that we've got. Okay? So now you got another rectangle. All right? And you got a triangle on the inside. So what we're trying to do is we're trying to find the probability of throwing a coin and it lands in our shaded region. So it does not land in that little space that is the triangle. Okay, so we're going to have a pretty high probability here, all right, instead of a lower probability. Okay, so again, are we taking out something? All right, what are we taking out in this problem? The triangle. So if I had to think about my probability formula or maybe my little cheat sheet, all right, what would I do here? What would y'all say?
You would do square.
Okay. Yeah, so square, or I'm going to call it a rectangle because I'm a math teacher. All right, rectangle, and we're taking out, so we're minusing, all right, or subtracting the triangle, and then it's all out of your rectangle, correct? Okay, so now once we know this, we can go do some work off of this. First thing we got to do is we got to get the area of the rectangle. So what's the area for my rectangle here? All right, you got what? Base times height, so 20 times 12? It's 20 times 12. 240? Okay. So 240, square units. Okay, we can talk about units. All right, again, I'm a little bit more concerned with just the numbers. And then what's the area of my triangle? I'm just going to draw the shape because I'm lazy. I don't want to write triangle. All right, area of my triangle. So it's what, 1/2 base times height? Or you could think about it like base times height and then divide it by 2, right? Do that first and then divide by 2. A lot of different ways you could think about this. So what is that? 4 times 6, which is 24. 24 divided by 2 is 12. Okay, so I got my 2 numbers that I need to plug in. All right. So let's go ahead and try to do this in our little formula kind of cheat sheet that we got right here. Our way of thinking about the problem. So I'm going to take my rectangle, 240. I'm going to subtract the area of my triangle, which is 12, taking that out. And it's all out of my total, which is 240. Okay. So we got 228 out of 240. Okay, my question is, will that simplify? All right. What's one thing that you know will go into both of those? 2. They both will have 2 go into them. Good, Tyrell. All right, so if I divide both of these by 2. All right, 228 divided by 2, what is that? Is that 114? Is that right?
Yeah.
What's 240 divided by 2? 120. All right, will that go down one more time? Will that divide by 2 again?
Yeah.
Yeah, it will. Okay, because they're both even. So if it's even, I know I can divide by 2. So let's keep going. Somebody put 114 divided by 2 in their calculator. I heard it. Somebody. 57? Ooh, I like that because that's a prime number right there. All right, 57 over 60. Okay, I don't think that's going to go down any further. All right, 57's prime, so only 1 and 57 go into that. Man, I had a...
Can we just leave it at this?
No, it can go down one more time. All right. So 57 is not prime, like I said. That's why I like that you guys can check me. All right. And I just said it, right? I'm not the knower of all things. All right. You guys can learn some stuff. So that's a perfect example of that right there. So 57 divided by 3 is what? 19 over 20. Ooh, I like it. That's awesome.
You can't go down.
That one definitely can't go down for sure. Okay. Let's look at our third example. So, same story here. All right. I'm trying to find a coin in the shaded part. That's what all these questions are asking for. The probability of the coin in the shaded part. Now, what do you guys notice about what I got here? It's got two shapes. So what am I going to have to take out? Both shapes. Okay. So this one, my setup's going to look just a little bit different, but it's the same idea. So what's my total thing that I'm looking at? All right. The big rectangle. Did I give y'all dimensions on the big rectangle? No, so I got to add some more information into this problem, don't I? All right, let's say this big rectangle is 10 by 15. All right, now I think we have enough information to solve the problem. All right, so we know that we're going to have our big rectangle, so the purple rectangle. All right, the purple rectangle. Okay. And I'm just going to do it with symbols up here. Purple rectangle minus what? The blue rectangle. That rectangle minus that rectangle. Okay, y'all like emojis? That's a math emoji right there for you. Okay, so we got a hypothesis right here. Oop, 114, not 144. I can't write. All right, 114 over 150. Okay, do y'all agree with that? How do you get 114? What do we do?
150 minus 28 minus 8.
So my purple rectangle is 10 times 15, which is 150, right? Then I got one of my blue rectangles, the tall one, is 28 from 7 times 4. Okay, and then my other one, sideways one, is 2 times 4, which is 8. So I think the way he saw this, he did 150 minus 28 minus 8, and he put it over 150. Okay, and that will give you, all right, 114 over 150. Now, will this simplify at all?
Yes.
What can you divide both of these by?
2.
All right, definitely we know we can divide by 2. And we already did 114 divided by 2 is 57?
Over 75.
Yeah, over 7.
Over 75? Will that go down one more time?
Yes.
Didn't we already saw last time that 3 will go into 57. And I know 3 will go into 75 because 3/4 is 75.
19 over 25.
So 19 out of 25. Okay, that's definitely, that one's done.